Hey guys, let's talk about what we're doing today. Today you're going to come here under 331, click on these mechanical advantage notes and examples. What I have is I have two sets of notes. One are right here, which are to the point, and then some examples. And then I also have some detailed notes right here. So let's look at the mechanical advantage definition. When a machine turns a small input force into a larger output force, we say that the machine gives us a mechanical advantage. So basically, you want to put in less force, you want the machine to do a bigger work for you, okay? And that's what mechanical advantage is. You learned about these simple machines yesterday by watching those videos and answering those questions. You learned about lever, pulley, wheelbarrow. These are all simple machines. So let's talk about wheelbarrow example, okay, right here. The wheelbarrow in figure 2 has an effort arm 120 centimeter long and a load arm 40 centimeter long. What is the mechanical advantage? This is the effort arm right here. All right, the fulcrum is where it's pivoting, okay, where it's moving, and then the load arm is right here. So you're going to take the effort arm divided by the load arm. I would suggest please go ahead and write this formula down. Mechanical advantage is effort arm length divided by load arm length, and your mechanical advantage is going to be 3. Notice there are no units, okay, because the units get canceled. So mechanical advantage is a number without any units. Okay, so let's scroll down and come to the pulley system. One of the pulley examples that we have in our school is the flagpole. Okay, so the person that's pulling down the string is putting in some force, and the output force is exactly the same as the input force because it's a fixed pulley system that we're using. So the mechanical advantage, where you're just changing the direction, is going to be 1. For that type of system where you're just changing a direction is going to be 1, okay? So the formula for mechanical advantage in a pulley system right here is input distance divided by output distance, okay? That's the formula that we're using. So to lift a load 5 centimeter with a pulley system, 15 centimeter of string had to be pulled. What is the mechanical advantage? So the input distance is 15. You're going to do input divided by output, and your mechanical advantage is 3. Remember, the bigger the number, the better of a machine it is. Okay, so the pulley system has a mechanical advantage of 3. And then we have another example right here. Talking about the forces, we're using a lever right here, putting in 25 Newton force, and the output is 250. So you're going to take 250 divided by 25 right here, and you'll get 10. So this is a very good machine because your output force is bigger, okay? And the force that you are putting in is smaller. Now let's go back to the other notes that we have right here, and those are going to look like this. Okay, so mechanical advantage can be thought of in 2 ways. How many times a machine multiplies your effort force, and how many times easier the work seems while using the machine. Example, a mechanical advantage of 5 would make the work seems 5 times easier or make you 5 times stronger while using the machine. Okay. All right, so mechanical advantage has no units once again. Remember what we talked about, when the direction is being changed, the mechanical advantage is going to be 1. Here are the formulas. This is talking about the effort force and the resistance force and the mechanical advantage. Please draw these triangles down. You have your effort distance and your resistance distance. And then I went ahead and put in one more, which is for the ramp, okay? We have a ramp in our school by the freshman building, okay? So the input distance divided by the output distance is going to be your mechanical advantage right here, okay? All right, so let's see. Here are some of the examples right here, okay? If you put an effort force of a 200 Newton into a machine and the machine produces a force of 800 Newton, what is the mechanical advantage of the machine? So what we're saying is, well, what's the advantage of using this machine? So the advantage is going to be that the output force is 800 Newton, which is going to go on the top, and the 200 Newton. So the bigger number is going on the top and the smaller numbers at the bottom, and your mechanical advantage is 4. All right, so that's your formula for mechanical advantage. Resistance force and the effort force. Resistance force is what the machine is doing, and the effort force is what you're putting in. Let's scroll down. You apply a force on a crowbar to open a stuck door. The effort distance of the crowbar is 26 centimeter long, and the resistance distance is 4 centimeter. Find the mechanical advantage of the crowbar. So you're looking for mechanical advantage. Your bigger number is 26. That's going to go on the top. That's your effort distance divided by resistance distance. So 26 divided by 4. Your mechanical advantage of using the crowbar is 6.5. So it's pretty simple. Once you understand the notes that I've given you, please watch this video to completely to understand the whole thing, okay? All right, now let's go back to the worksheet that you're doing. Here's the worksheet that you're going to be doing. It says fun with mechanical advantage. This is the worksheet that you're going to be doing. All right, once again, 3-step method. Please put down the formulas that you're going to be using. I hope there are no confusion. If there is, please contact me and let me know. Send me an email or whatever, and I'll be more than happy to answer your questions. Or you can contact me through Canvas. Okay. All right, guys. I'll talk to you tomorrow. Bye.